That's fantastic. Thank you so much, ladies and gentlemen. We are rapidly moving, and we are right on time with what we have desired to do today. I want to believe that you've all had a great time during the third networking that we just finished. This is a wonderful opportunity for you to engage, to interact, and we know, from previous experience that deals will be struck even during this period. There will be opportunities to collaborate. Please, let's have an open mind. Without much ado, we're moving to the fifth presentation, and that will be handled by Kirit. Kirit is from the NOV. He's been a friend of Produced Water, not just in Africa, across the world. Please, ladies and gentlemen, join me to welcome Dr. Kirit to the stage. You're welcome, Dr. Kirit.
Thank you very much, Dr. Wilson. Thank you. Okay, let me share my screen and start this presentation. Okay, hopefully you guys can see my first slide.
We can see that perfectly.
Excellent, excellent. Okay, so obviously I'm going to talk about produced water and the risk-based approach. So this is a process where we actually manage the produced water. I guess you guys don't need any introduction to what produced water is, but it's obviously the water that's injected to get the oil out, and it's also the formation water that comes from under the seabed. So the company that I'm with is NOV. For those not familiar with us, NOV is National Oil Well Varco. So just basically, we have a global footprint. As you can see, we're present in something like 64 countries with quite a large number of employees, 36,000 plus, and heavily involved in providing solutions, technology. The particular unit that I'm in is actually the environmental unit, and it's based up in Scotland on the island of Flota. So it's quite remote, but ideally placed in terms of the North Sea and the oil and gas sector. In terms of the presentation, what I'm going to talk about is the actual risk assessment methodology. And as I say, based in the UK, we've been heavily involved in the UK implementation program right from the outset. So we're liaising closely with the regulator actually, and also been heavily involved in other global aspects. So I'll also try and give you some global perspective on this approach, and then show you some example in terms of what it is that we're talking about, and the nuts of the RBA, if you like, and some future considerations in terms of the global perspective. So let's start with the basics. When we talk about risk, and in this context, we're talking about ecotoxicology, toxicity of produced water. Therefore, the three relevant terms that you will see mentioned, if you like, are dose, effect, and exposure. So, what's the dose of the toxicant? What are its effects? And, what's the exposure? What are we talking about in terms of exposure of the organisms? At the end of the day, what we're interested in basically is what is the safe exposure. So we have all these toxicants coming in terms of the produced water, but we want to establish what is the safe exposure for those different toxicants. So the way to do this is really to look at it in terms of, and this is a classic flow chart actually, and it applies to not just in this context in terms of produced water, but any risk really. You could be talking about monetary risk, financial. Again, the concept is the same. You have your data collection, you have the hazard. What is the hazard we're talking about? What's the exposure? And how do you assess the risk characterization? So for the hazard assessment, we have to identify the hazard. What is the risk source basically, and then we actually look at the nature of this adverse effect. And then in terms of the exposure, is obviously in this context is the discharge, environmental interaction. And then essentially what we're trying to establish is this probability. What is the probability of this risk taking place? And in order to do that, we need to actually do the risk management. And then obviously that needs to be monitored on a continuous basis. So that's kind of the crux of the risk assessment. To say right at the outset is that we use this concept of PEC-PNEC. So this is a ratio of PEC-PNEC. So predicted environmental concentration and the predicted no effect concentration. So putting it simply, is basically the concentration that's in the field, and PNEC is the concentration that we establish from the tox testing in the laboratory. Now, the whole rationale behind this slide is actually there are certain assumptions that we make, and this actually brings an element of conservatism, some speculation. So it's a good science, but it's not exact science. That's my take-home message. This is the definition of PNEC, what we're talking about. So PNEC is the concentration which unacceptable effects on organisms will most likely not occur. Now, the big assumption that we make is that the ecosystem depends on the most sensitive species. So if you protect the most sensitive species, then you protect the whole ecosystem. I have to confess that that doesn't necessarily sit well with me, because that's not necessarily the case. It's an assumption that we make. So you must bear that in mind. In terms of the information that's available, again, that's quite limited. The pool of data is limited, and we have to use short-term toxicity data. And again, therefore, we have to apply assessment factors. In terms of the concept that's involved, we have different terminology that's used, and therefore, depending on which test we use, it'll bring different assessment factors. So just bear that in mind, that it's good science, but not an exact science. So there are assumptions that we make, and it brings an element of conservatism. And this is the concept we use, the PEC, and this gives the indication of the likelihood of adverse effects. So how likely is this adverse effect going to take place? This is sorry, noisy slide, but this is our kind of flow diagram for the RBA process in the UK. It's a stepwise process, and the idea is that the regulator can actually screening cut off at any particular step depending on the outcome of the actual assessment. So we've completed the first cycle, and we're now in the second cycle, or about to commence the second cycle. And different steps, as I said, this relate to that flow chart I mentioned about hazard. And so basically that's the data collection, and then we actually assess the hazard, and you'll see this when I show you some real examples. So the data collection involves looking at the chemical analysis of the produced water, and operators in the UK continental shelf are required to actually perform chemical analysis on produced water twice a year. So this is the data we use. And for toxicity, we actually use different trophic level species. So we have microbial assays, algae, and we have crustaceans. So the different, this is different, the hierarchy, if you like. And as I said, this is the process. And you'll see when I show an example in terms of, what information we obtain. So what we start is with the produced water, do the tox testing, use the chemical analysis data, and then we do some modeling, and then that will tell us where the toxicity is coming from. And therefore, you can have a risk management plan. So from a global perspective, as I said, I'm based in the UK, and we're involved in the UK continental shelf, and we are governed by the OSPA regulations. And again, you'll see that there are. So, for example, Norway is one of the other countries that's involved in this regulatory drive. In other regions, and the regions that I've actually indicated here are regions that are where you see the most number of offshore platforms. So this is where there is the most amount of activity offshore in terms of the oil and gas. So in terms of the produced water discharges, this is where these are going to be quite important, if you like. So you have the Gulf of Mexico, and you have the US regulations off the coast of South America. And for example, IBAMA, the Brazilian regulator, controls the regulations there. You have further away in terms of Australia and Far East. Again, Australia and Far East have specific regulations. And then you have off the coast of Africa. And again, here, for example, you have the Abidjan Convention, which actually plays into play. My take-home message here is the fact that there are these different regulations, and if you look at the specific information that I've indicated, there are different concepts used. I showed you that flow diagram in terms of how we actually make the assessment, and if you look at the particular data, again you'll see that the approach is different. That's my take-home message. The approach is different, so there is that parity in terms of the different regulations globally, and that's what I'm kind of trying to say. And this just really kind of exemplifies that. So, that flow chart I had initially where we've got the data collection, the hazard, the exposure. Again, as I mentioned in the previous slide, if you look at the specific information, so for example, in some countries, in some regulations, you have a specific, like for example, we use assessment factor, where in other countries you have a species sensitivity is used. I mean, the PEC-PNEC is obviously relevant in most contexts, but the way this is used is actually different, and that's kind of what I'm trying to say here in terms of the fact is that tremendous disparity in terms of the different regulations globally. So the other thing to actually highlight is the fact that we produce water and the oil and gas sector. So obviously the regulations that I talked about in terms of the oil and gas, they're obviously important. But we're talking about chemicals here. The whole idea of risk-based approach, as I mentioned, is to look at the toxicity of the chemicals. And you have chemical compliance regulations as well, which are applicable globally. And the most prominent one, and I guess most people would be familiar with, is the REACH regulations. And my important take-home message here is that if you look at the REACH regulations, they are in different stages, if you like, globally. So, for example, if you look at the green dots, this is where REACH is already, if you like, in place. So it's actively practiced. So Korea, China, and obviously Europe. The other regions and the yellow dots indicates that is basically where these are actually regional states. So US, in South America, South Africa, India. Again, these are at the provisional state. And so you have those two regulations, the oil and gas regulations, and you have the specific chemical regulations. And the point I'd like to make is that there needs to be a harmonization, if you like, between these regulations and the chemical regulations. And what you find is actually that harmonization is not there at the moment. So again, that's an important thing to bear in mind. It will become more important that we actually make sure that these are harmonized. So in order to actually carry out the risk-based assessment, again, there are certain aspects that need to be in place. So, in talking about the infrastructure, as I mentioned, we obviously have the regulations. So the regulator obviously has to make sure these are actually adhered to. And in most cases, it's the Environment Agency in that region that actually takes care of that. Obviously, you have the operators, the oil companies that have to actually comply and actually have to, basically, verify and actually carry this out. So again, this is very much an international, practice. And, as I said, there is already a disparity, but a lot of the operators are global. So, the big operators actually operate in different regions globally. So they have to comply with different regulations. Um, and obviously you have the chemicals that are used and you have the suppliers that obviously supply these chemicals. And again, these chemicals need to be registered in a correct way. And I mentioned about the different regulations. So again, you have the specific regulations in response to the chemicals. And then in order for this, risk-based approach to be taken, to be carried out, you obviously have the chemical analysis, as I mentioned. This is obviously important. And historically, this is what's always been done, not just in terms of offshore produced water discharge, but any regulations when it comes to toxicity. You have the chemical analyses, but we're moving more and more towards ecotoxicology. So what we're saying is that chemical analysis is alone. You need to look at the effect on the organisms, and you need to look at whole effluent toxicity. So that's again important. And again, for this to happen, you need to have the laboratories to be able to do that. And you need to have appropriate accreditation. So for example, we are a GLP lab, good laboratory practice. And again, in different regions, the point I would make is that these laboratories just are not there. They don't have the scope to be able to do all this. And if you look at it globally, again, my take-home message is that the infrastructure just isn't in place to the extent that it should be. I mean, it's there in regions like US, Europe, but it's not there everywhere. So again, that does raise some issues. If you look at the RBA, risk-based approach, in terms of chronological development, again, this is very recent. kind of the important message that I'm trying to establish. So the regulation came into play back in the 1960s. They were quite basic. So you were just looking at oil and gas discharge, and these were end of pipe regulations. And then over the years, they've actually been modified, developed, and you can see basically most of this have been in like the US and European regions. And you have specific OSPA regulations that came into play. There was more development as we see, as it progressed, for example, as in Nigeria. So it's progressive. It's been progressive, but it's very recent. That's kind of the message. And if you look at this risk-based approach, this has only come about, if you like, in the first decade of the current century. And if you look at the UK RBA trial I mentioned, again, this only started sort of back in 2012. In terms of the first cycle, we've actually finished the first phase, and then we're in the interim phase now, and then 2023 is where the next phase will start. Again, there are other countries, this is now being practiced in. So this risk-based approach is globally taking momentum, is gathering momentum, but it's recent, and I guess it needs time to actually be practiced. So we were actually commissioned by IOGP, which is the International Association of Oil and Gas Producers, to look at this, globally in terms of, the disparity I mentioned, and how do you actually address this RBA? So we were involved in, producing this guidance document. Again, it's in the public domain, report 6. Again, I would say, please do have a look at it. It's very important. It's useful, and we put a lot of information together. You know, the disparity, but also how you can actually carry this out. So it goes a long way towards global unification. I did say at the outset examples in terms of how we actually do this in terms of the specific that stepwise process I mentioned. So the modeling we do the chemical analysis, we do the tox testing, we do the modeling, and this is just for your purpose. Example shows you the outcome. So for example, from the modeling, we can see here, for example, this is your point of discharge, the small dot in the middle, and this shows you the risk. So obviously the risk, the darker the color, the greater the risk. So you can see as the produced water is discharged, the greatest risk is close to where the discharge is. And then obviously with the currents, the tide, and the wet ocean conditions, the discharge will actually dissipate. So the risk becomes less. And we can look at it, cross section, 3-dimensional. And here you can see for this produced water, this is the water surface, and that's the seabed. You can see the risk was greatest close to the surface, whereas in another case, another produced water, this risk was greatest close to the seabed. So what I'm saying is that the ecosystem that will be affected will be different depending upon the particular discharge and the particular produced water. Again, that makes a difference. What we can also do is look at the different chemicals, as I mentioned, that are present in the produced water. So from the modeling, we can actually home in on where the toxicity is coming from. So here, for example, in this particular case study, we can see a corrosion inhibitor was actually was contributing the most to the toxicity. We also had this H2S scavenger, which was contributing. And then we can also look at the naturally occurring chemicals. So these are chemicals that should come from the formation from the water from below the seabed. And again, you can see which particular chemical coming from the naturally occurring substances. So hopefully that gives you an idea of the concept and what we actually obtain. This just shows some of the it's a process, it's a dynamic process. So UK continental shelf, we actually learned from lessons learned, we modified the approach. So the two key parameters that are used in terms of assessment factor for the earlier steps I mentioned are the amount of water that's discharged, the amount of produced water discharged, and to what depth you're discharging. And then we use these different assessment factors that we've derived. Again, this was modified so that we introduced some more interim discharge volumes, so it gives a better representation. The other thing that we were able to do was to look at the actual modeling that was done. So for the most part, we've used this DREAM model. It's a proprietary model. And, there are other models available like Comics, Mike, and, development of other models that can be used to do this, to make it, more accessible globally. The other point to make is that, I mentioned about different organisms, different tests that we use. And again, you can see here, for example, when you look at, you can see they are sensitive to different, or put it the other way, different organisms are different, have different sensitivity to different produced water. So it's important that you actually use different test species. This is again quite important from an ecotoxicological perspective. To mention is that when you look at production chemicals, they are actually made up of different components, and obviously that's available, particularly in terms of the process, and is that the amount of information available is very specific. So actually making this assumption. So, for example, the production chemical will be made up of different components, but the information we have would indicate, for example, that one particular component is very toxic, but this component might be, just a very small percentage of the whole. But because of limited data that's available, then we end up treating the whole product as though it's that single component. And that actually creates this artificial, impact, if you like. And I mentioned earlier on that, this is a good science, but it's not an exact science, and it's a little bit speculative. The other element of speculation that comes into play is when you use chemicals through the process, the chemicals will actually partition between different phases. So you have your oil phase, you have your water phase, and your gas phase. So those chemicals will actually end up in those different phases. But we make the assumption that the chemicals you're using, all the chemical ends up in the produced water in the discharge. Well, that will not be the case. So again, that's an assumption that we make. And we are looking into this in terms of, we're involved, for example, in a working group, to see, where the partition takes place and try and modify the approach. The other area where we want to try and actually improve that sort of speculative aspect is to use different species and to use different type of tests, so we can actually reduce the assessment factor. So here we're advocating the use of chronic testing, and this is something we're actively looking at already. Mentioned we're entering the second phase, and in the second phase we will actually be using chronic testing. So these are more elaborate tests, and again, this will give us a better picture of the outcome. So here again, you can see in the second phase for the UK, we have all these different operators, and these are all the different relations that in the coming years will have to carry out the RBA. We will be heavily involved in this. At the moment, we're already involved with this various platforms here. So that's the future. In terms of this particular plot, you can see over the years, from a regulatory perspective, the objective has been to actually reduce the amount of produced water that's discharged. So, that's been the idea. So over the years, that has actually been going down. What's actually been going up is the amount of water that's actually reinjected. But if you look at the continental shelf, you can see that the amount of reinjection that takes is only something like a quarter. A quarter of the produced water that's actually produced is actually reinjected. So even if you were to reinject everything that's produced, it would only be a small percentage. And the reason I say that is, if you look at, this was a study carried out in Norway, if you look at solutions to trying to reduce the EIF and the toxicity, there are different avenues, different ways to do that. So you might substitute the chemicals, or you might, use reinjection. But you can see the cost of reinjection for a lot of these different installations was pretty high. You're talking about in the millions, six-figure sums. So what I'm saying is that injection is not necessarily the answer. You do need to do something about the toxicity of produced water. And as I say, although the produced water is going down, in terms of what we really need to do is look at what's actually in the produced water. So you have different risk components. You have your low risk, medium risk, and your high risk components. And what the regulator needs to do is to make sure that it's this high risk components that are actually, less and less of these are discharged. So that is the recipe really in terms of reducing the impact. And I'm time. So just to end this presentation, a final summary. As I say, you need to review the methodology that's used in terms of the whole RBA process. I mentioned about different tests. So again, the assessment factor by using chronic testing, chemical substitution. You need to use chemicals which are less harmful to the environment. Use improved water management strategies. Again, here we can use BAT, which is best available techniques, best environmental practices. And as I mentioned, there is tremendous disparity globally. So again, you need to have a unified approach globally. And then, as I mentioned, the infrastructure in some places just does not exist. So we need to make sure that, globally we address this. We have a unified global approach to actually improving the infrastructure. And that's the end of my slide. So thank you very much indeed for your attention. Appreciate that.
Thank you so much, Dr. Kirith. That's a wonderful, wonderful presentation. And one very, very important aspect of your presentation, delve on data, risk, hazard, monitoring exposure, and the most important is actually the global regulation.
Absolutely.
I mean, well done. That's a fantastic presentation you have given us today. Before we delve into we have one or two questions in the chat. We all know that regulation is key across Africa. We'll be focusing because we had our first event in Nigeria back in 2019. The regulatory space in Nigeria is becoming very robust. And if you twist that and switch to Angola, switch to Ghana, and all the operating countries in Africa, there is real focus on regulation. Absolutely. And there's a shake-up within the regulatory system in Nigeria. The presidency has actually created a regulatory board. And if you are doing business in Nigeria, you need to familiarize yourself with the Petroleum Industry Act, which is very, very key. And then, without much ado, whatever happened in the North Sea, in the Gulf of Mexico, or anywhere, Africa must tap into this global technology. And we want to thank you, Dr. Kirith, for that wonderful presentation.
Pleasure. Thank you very much indeed.
You're welcome. The first question is coming from Kingsley. He's saying, Dr. Kirith, how effective is the application of AOP, photocatalysis, treatment technology in the treatment of oil field produced water? You said reinjection is not the solution, and that the solution that reducing the toxicity is the best solution. Maybe you want to expatiate on that.
That's a good question. It's an important question. I think it's a valid question, and I think we need to look at all possible avenues. So I mentioned about using different chemicals, but I'm conscious. For example, some chemicals you cannot actually substitute. Like biocides, they're designed to be toxic. They're designed to kill. So looking at like AOP, I think that's important. We NOV, for example, we are involved in technologies development, providing solutions. So I would say, that's a really important aspect. Photocatalytical analysis treatment is an important consideration that operators should bear in mind. And I think that's where we're going. We're looking at improved technology, which will actually, as you said, Dr. Wilson, reinjection will not be the solution. So such avenues we should explore for sure.
Thank you. Thanks, Dr. Kirith. And we know that chemicals is a big, big aspect of produced water globally in terms of effectiveness of managing produced water. The question coming forward again from Emmanuel Oduwole is saying, thanks. What's your view on treated produced water optimization and evaporation into the atmosphere?
Actually, that's a good question. I think not many people think about it. Basically, I think it is relevant. It has a certain implication. For example, there are volatiles, in the produced water, in the discharges that will be impacted. And I mentioned, the partitioning between the different phases is again very important. Really important that you actually look at chemicals in terms of how they partition, how they break, how they atomize, and that's really quite important. And the chemistry is I think that's really again a good take-home message, really, and a good point, basically, that chemicals are different by nature. and different components behave differently. So that's point. And I think, again, that's something which is important. So all those aspects of the chemistry, the processing side is very important, and the regulations, as you said. And if I just take a moment to address the point you made, Dr. Wilson, about Africa. And I chair a working group on the Abidjan Convention, and you're quite right. There's a lot happening. So I'm really excited that Africa is really opening up and doing something about this. So it's a valid point.
Amazing. Thanks so much. And then, chemical injection and whatever is it's a big business even in the industry at the moment. And the essence of today's conference is to open up that space. We can be creative, we can be innovative. We've got another question coming straight away because this is becoming exciting now. Dr. Kerry, thanks for opening up this space for us. Does evaporation reduce the echo effects?
Yeah, yes, to be honest, evaporation will have a limited sort of impact, if you like. I think more, I think the impacts in terms of the aquatic environment, predominantly the concern tends to be with with what's actually in the water and, the ecosystem that way. But, we're involved in looking at RBA, and we do a detailed assessment of not just the aquatic environment, but mammals, seabirds, and that does have an effect. As I said, there is a speculative element of this, and in terms of monitoring, again, I think that's a really good point in terms of evaporation. There isn't enough monitoring done. I mentioned in the flow chart that you do this assessment, you make the predictions, and I'll be quite honest, that the predictions say this will be the impact you might have, but there's not enough done to go out in the field and do this. So, and again, these are really good questions. What happens in the field? Do the chemicals get evaporated? In the process itself, what is happening, and what can you? I think this is really good. I like the fact that there are people asking questions about the chemistry, about the mechanics, and so this is really important. Yeah, good question. Absolutely.
Amazing. I think the turning point of your presentation is the fact that you mentioned BAT, which is the best available technology. I want to re-emphasize here that Africa deserves the best approach to technology.
Absolutely.
We want to have a continent that is free from poisonous activities, that is free from any form of environmental degradation, where we can all compete globally and say, yes, we are following the right thing. Again, there's an award going out in the chat to one of our very, very good participants. We want to keep this warm. We want to keep this live. Today's event is about you, the participants. We want you to be activated. Brevity Anderson, the world's best event management company, is already issuing an award to Emmanuel Oduwole for his creative questions. I think a shout out to Oduwole Emmanuel for most of the questions you've been asking. We've got another question here, minding the time, so that we can quickly go to our next presenter. The last question from Kingsley Amakri. I think Amakri is actually joining on the queue to get a golden award from Brevity Anderson. Yeah. So the question reads, regulation, Dr. Wilson, there is no data on produced water discharge in terms of BTEX, phenol, and PHAs. Why are they not regulated in Nigeria? First and foremost, I will be dealing with this. I want to bring it to your attention that the regulatory space in Nigeria, Dr. Kingsley, or Kingsley Amakri, is under the auspices of DPR. And DPR have a robust plan for all operators across the upstream, midstream, and the downstream sector. The good news today is that the President of the Federal Republic of Nigeria has assented his consent to a new law called the PIA, the Petroleum Industry Act. And the defunct DPR will now be under the umbrella or portfolio. Part of it, I'm aware, with the upstream regulatory board. Be rest assured that all the work, the hard labor of the DPR will be reviewed. And your question will probably be focused. If we were privileged to have DPR with us back in 2019. I'm aware we have some DPR in-house today, but their assignment is not to contribute. Their assignment is to listen and to support us in the background. So we will be sending this question out, but be rest assured that Nigeria is not an isolated country, Kingsley. Nigeria is operating in a global environment. And in terms of compliance, DPR is doing its best in Nigeria. And I'm aware all the other African countries, they are borrowing a leaf from Nigeria because Nigeria is the oldest oil producing country. So we will explore the possibility if there's any lapse in terms of regulation that covers BTEX, phenol, and all the other chemicals that are in use in the oil and gas space in Nigeria. We will be going after the regulators and probably make a case for them. So thank you for bringing that to our attention. And it's been a great pleasure, Dr. Kirit. Thank you so much for your innovative presentation. And is there anything you want to say to round up before we let in our next speaker?
Absolutely. No, thank you very much. I really do appreciate this opportunity. Brilliant platform, exciting audience, and as you say, some key milestones. And you're quite right. There are regulatory developments which are going to be important. So, well done, Africa. Absolutely. Thank you.
Amazing. Amazing. Thank you so much, Dr. Kirit. And let me get Lucy on. Lucy, do we want to have our next technical presentation? I think we have Envirotech Systems, but
Mr. just coming up.
Lucy, over to you. So, good news.
Good
now,
morning.
Before we start, ladies and gentlemen, we want to thank you for today. It's been a great privilege. It's been an exciting moment. Just for you to know, Envirotech Systems is one of our sponsors, and we are very delighted to have Jean-Marc with us. He's a friend of Produce Water, not just in Africa, but globally. I remember having him around in Lagos back in 2019, and we are privileged to have him here to share with us industry technologies that will help all the audience today. The floor is yours, Jean-Marc.
Thank you very much, and good day to all. Let me share my screen so that we can start the presentation. Okay, hopefully you can all see this. So thank you very much to the Produce Water.
Sorry, Jean-Marc, we can't see the presentation yet. You may need to go back to the Remo tab and press share screen there.
Okay, I will do that. Share. Oh, yes. I think this will work.
Yeah, we can see that now.
Is that better? Yes.
Yeah,
okay.
Perfect.
All right, sorry. So I would like to thank Produce Water Management Conference Africa for inviting me to give you a presentation today. Also, I would like to thank Steve Coffey and also Magnus Ekekwe for their leadership in putting this event together so that we can all be more aware of the Produce Water technologies available and how to have better management, better treatment, and better reuse, or depending on what you're doing with your produced water, to have minimum impact on the environment. So I would like to introduce myself again. My name is Jean-Marc Dumontet. I work for Envirotech Systems, and we have offices in various locations. Our main office is in New Orleans. That's where I am right now. We also have offices in Bakersfield, California, also in India, and we have also many partnerships with different partners around the world, including Latin America, Africa. Envirotech has a global presence. We do projects all around the world. And Envirotech is really, over the years, over the decades, has been specializing in produced water treatment. So we have expertise in all fields related to produced water, and we can work with customers or operators from the early stages of the FEED project getting involved in all the steps, the engineering, the design, project management, fabrication, all the way to commissioning of the equipment and the startup, so that once the equipment is in operation, the customer can have assurance that their equipment is working properly and as designed to do the right thing and to obtain the water quality that was expected during the design. Before I get into the real subject of today's presentation, which is a focus on oil and water analyzers for continuous monitoring of the water quality before discharge or before reuse, I would like just to share with you a brief general view of produced water technologies and how we can achieve the desired water quality. So in the world of produced water, all applications are a little bit different. There are different concentration of oil in the water, and also there's different requirements before we discharge with specific concentrations. Unfortunately, we can't do this with a miracle one equipment fits all, because they all operate within a certain range and different concentration, and most importantly, the oil droplet size will dictate how well your equipment will operate. So, you know, here you can see that the oil droplet size, the larger it is, it correlates most of the time to the overall concentration of oil in your water. So the higher the concentration and the higher the larger the droplet size, you want to treat it with primary stage vessels. As shown here, you got API 421 separators, hydrocyclones, plate packs separator, CPIs, and those are well suited to remove most of the free oil, larger droplet size, before you can further treat it if necessary, if your application requires it, to send it to a second vessel, secondary stage of treatment like flotation that you have here, in combination with the chemicals, everything in the produced water. We can use our own gravity separation equipment, but it all is done in conjunction with good chemical treatment. And if you need to treat it further, then you can use a tertiary piece of equipment like filters, coalescers, and membrane filters if you really need to remove all the impurities. But as you can see, these steps are done so that you have the right equipment depending on the oil concentration. Okay. Here on this slide, I'm just giving you an overview of different equipment that we can provide customers to achieve what is required in the project. So here at the top, you have a skimmer and or CPI that would be considered first stage of treatment, where you can remove the higher concentrations of oil and water before you send it to a second stage of treatment, here shown as the IGF flotation unit. And again, if you need more or further treatment, you can have a tertiary treatment system here shown with this filter media and bring the oil concentrations down. Or also, filters can be used as a assurance if, let's say, you have an upset condition where treatment was not done properly in the first or second stage. You can always use the media filter to give a performance guarantee to the customer before you discharge overboard or reuse. And this is where I would like to share or focus on the oil and water analyzer, which is shown here right there. At the end of the treatment package, and this oil and water analyzer is used by customers to give them a real live account of what the water quality is and be able to confirm that this water can be further discharged or managed downstream without impact on the community or on the environment. Okay, so now, on this slide, I'm showing the oil and water analyzer installed at the end of the treatment package, but we can also install them at various stages of the produced water treatment package to also confirm good performance of the equipment. We can install one downstream of the skimmer or a couple analyzers in front of the IGF, downstream of the IGF. So all projects are a little bit different, and customers require sometimes to have a better understanding of their process. So these analyzers that complement very well the equipment that we can provide the customers at Envirotech, regardless of it's a first stage treatment, second stage treatment, they come in various styles. Here I got a probe style analyzer on the left or a side stream analyzer on the right. If you have a new installation or you want to have a better inline measurement, maybe more accurate would be the probe analyzer. If you don't have the flexibility and your existing installation cannot be adapted with a probe, we can also provide the side stream analyzer, which is shown on the right. We have explosion proof analyzer like here, or we can have general purpose analyzers shown here. On the right side, you have a probe style, similar to the previous slide. And also you have a handheld analyzer that you can use for spot measurement all along your produced water package to be able to confirm that you are achieving the separation as expected. So this is useful for the operator to either make sure everything's okay, use it in his lab, and correlate with the other inline results. So over the years and decades, oil and water analyzers have evolved quite a bit. They are much more reliable. They can keep themselves clean, and they are meant to operate in a harsh environment like we have in the oil and gas industry, offshore, onshore. So these equipment have also a very high performance. They can give you very accurate measurement and also real-time information with readings every second. So you have a real-time information coming to the DCS or to the customer's control room. And finally, we can use these analyzers that are very accurate to also control, like I've shown in my previous slide, to either use filtration when required and if you have an upset condition. But if, let's say, your water quality is already achieved, you can use this analyzer to divert the flow using a three-way valve, and you can avoid using your tertiary treatment if you don't require to. So for the customer, it's a reduction in operation expenditures. So these analyzers that we have are robust. They can operate on their own without any assistance. They also can clean themselves. That's why I'm showing here that zero maintenance or very little maintenance. Operators don't need to clean these analyzers constantly to get the accurate readings they need. Accuracy, very accurate within plus or minus 1% of the measurable range. Very reliable. We have explosion-proof analyzers if required. And it also has various connectivity possibilities with the customer's DCS system, 420 milliamp, HART protocol or Modbus protocol, and also Wi-Fi and Ethernet. And nowadays, these analyzers are really easy to operate. There's very little intervention. Once it's commissioned and running and calibrated, it is going to keep reading properly with minor tweaks if required when we correlate with the lab, but they clean themselves and it requires very little attention. So the analyzers that we provide has various technology that have evolved through the decades, but it has ultrasonic cleaning device. It has fluorescence or laser-induced fluorescence technology, video microscopy if you require it for further analysis, and if the customer is more interested in water analysis instead of just knowing the ppm level, and also spectrometry if you want to use this feature to recognize different types of oils that can be introduced in your produced water, if there's interference with chemicals. So using the spectrometer will allow you to avoid some of the challenges using this laser-induced fluorescence. So the technology around the laser-induced fluorescence here on the slide, you can see that we have the measurement chamber here, or where the probe analyzer could be introduced in the process line, where you got the water flow going through here, the inlet and outlet. You have this laser that is shining in the process through a sapphire lens. So this laser and UV light will activate or will energize the hydrocarbons that might be present in the water. And this energy is converted back through fluorescence. And the reflection back is sensed here through this other connection, fiber optic cable, to the light detector, where in this case, it could be a spectrometer. So this is basically the technology of the laser-induced fluorescence. You use a specific light source, like a laser, UV light. You excite the hydrocarbons, and the measurement of that fluorescence is then converted into a ppm, using or making sure that we did a proper calibration. So that is an important step that you have to do to have accurate measurement. Is before, when you commission the analyzer, this calibration that you do will be done specifically to the site-specific oil type that is present, because each oil is different. So you have to make sure that the analyzer is calibrated properly, and you will get an accurate measurement. So this slide is showing you the advantages using a spectrometer. Here you can see different spectras of constituents that you might encounter in your water. And sometimes, you are trying to measure the content of hydrocarbons, but you could have a interference coming from other contaminants. Like here on this slide, I'm showing an emulsifier, which at a specific wavelength can be considered as your oil concentration. But instead of, let's say, knowing the information from a spectrometer, you can change the wavelength at which you're measuring, so that you can minimize interference from the emulsifier. In this case, we would just make sure that the analyzer would be calibrated and a measurement done at a higher, longer wavelength, so the interference would not be as impactful. Here, another technology that we use using oil and water analyzer is sometimes customers require to troubleshoot their existing process. And knowing the ppm level of the oil in the water is important to know. But when you have, let's say, limitations on your equipment and you're not achieving the results that you want, sometimes it could be a revision to your chemical treatment plan. Sometimes you have issues with your oil droplet size being too small, so the equipment is not achieving the performance. So using the microscopy analyzer, which uses a video or a picture, a series of pictures, as you can see here on the right, you can distinguish the various constituents of the water, which could be oil, it could be gas, it could be also solids particles. So this analyzer program has a software to recognize the different shapes. So you know what is an oil particle droplet, what is a solids particulate. And you have different features to tweak around to make sure that it is properly calibrated to recognize what is a round shape, which would be a oil droplet. An irregular shape would be a particle. And a round shape with a donut inside would be a recognition of a gas bubble. So all of these can be adjusted through the software, and you can, at the end of the day, have a series of pictures here with the software recognizing the particles, the oil droplets, and the gas bubbles. And you can have an accurate oil droplet size distribution, or also a TSS content with a particle size distribution. And you can further analyze it in the lab to make sure that, okay, well, if there's an issue here with the oil droplet size, you can address it with maybe a revision to your chemical treatment upstream. So that gives the customer the ability to understand the process more than just using a laser-induced fluorescence. Our analyzers have the ability to self-clean themselves. You can adjust the frequency at which they are operating. You can also adjust depending on the temperature of the process and also the pressure in the line. The ultrasonic device can be tweaked to operate at different frequencies. You can also adjust the intensity to be stronger or less strong to dislodge any impurities. So here on the right, you can see the actual tip of the probe, which would be inserted in the process. Once you have once it's triggered, I'm going to start the video so you can see here. So this demonstration is showing you the extreme condition where you ramp up the power at its maximum, how the ultrasonic operates. So you convert this electrical energy into a mechanical transfer all the way to the tip of the probe to be able to create cavitation in the water. And this cavitation, which has like gas bubbles if you want, will scrub the lens and make sure that no impurities have the ability to stick to the lens. So keeping this lens clean all the time will give you accurate measurement and avoid operators from constantly removing the probe and cleaning it. Here on this slide, I'm showing you the same thing, but you can notice the probe tip has been intentionally smeared with oil to show you how it will rapidly dislodge the impurities on the lens. So very, very important. Our analyzers now, and for a long time, have this ability. And that has shifted the general perception and attitude from the operators and everybody involved on the advantages using analyzers today to give you accurate measurement continuously with minimum maintenance for everyone that is involved in operating this analyzer. So that is what I wanted to share with you. On this slide, I'm showing you what could be the results if you have a fouling occurring in your process, and let's say either the ultrasonic is not operating or you're using a different technology, is that over time, you could have a false reading, and as the lens gets dirty and dirtier, you have a false impression of a lower ppm. But you got to be careful. That's why using ultrasonic will help you. So I wanted to share with you the advantages of the oil and water analyzer, not only for the operators, but also for a company like Envirotech, where we have a multitude of a piece of equipment where you want to make sure that it is operating within its specific range, and you're not having any issues or concerns that might be related to either water analysis problems and impacting your overall performance. So this completes my presentation. I'm ready to answer any questions if you have them.
Thank you, Jean-Marc. It's an amazing presentation. I think the focus is direct. I mean, this is a solution, as a solution provider, as an OEM in the industry. We are fully, aware of your expertise, the depth of, Envirotech in the industry globally. We are not surprised with the presentation. Is quite precise, distinct, and focused. You'll be privileged to know that there's a lot of challenge in the African continental shelves, especially the oil producing companies. They have lots of challenges with oil and water and all that. So we have questions rolling in for you here, John. So I'll definitely jump into some of the questions now.
Okay.
And we'll see how we can tackle them one after the other, bearing in mind our time schedule. First one is coming from, I think, we have some of our delegates already throwing questions to Blessing. So Blessing is focusing the questions here. Are the carbon footprints of these analyzers measured? That's the first one.
Okay, so the carbon footprint of the analyzer?
Are they measured?
So these analyzers will measure the hydrocarbons that are present in your water. Okay, so anything that will fluoresce will be measured in ppm, and will give you a confirmation if you're meeting your expected water quality before discharge. Okay.
Okay.
So these analyzers, in terms of carbon footprint, in the process of fabricating or making these analyzers, there's some carbon footprint, but during the process itself, there's very little carbon footprint. These analyzers operate using a 24-volt DC, so it requires very little energy consumption, and yeah, so these I would say have very little impact on the carbon.
Fantastic, John. So I've got another question here from Emmanuel. Emmanuel is asking, have you used, or can the analyzer be used to evaluate the total performance of a produced water facility?
Yes, of course. So depending on customers, sometimes they want to achieve different things. Sometimes they're only concerned of the water quality before discharge. But some other customers want to know all along the process at various steps if the equipment is operating or doing what it is supposed to do, and also gives the customer a more proactive position to detect early in the process if there's any unwanted performance on the equipment, or maybe operators on the platform or onshore might have changed some other processes that might have an impact on the water. So knowing some of the changes in your produced water quality and also pinpointing when these events occurred, you can trace it back and know what you did, or I mean, in the operator's mind, what they did that might have triggered this upset condition. So that is the advantage of having maybe multiple analyzers all along your process to recognize any upset conditions.
Thank you, John. We've got 2 other questions. A lot of questions are rolling, and this is a testimony of how, I mean, enthusiastic people are. The delegates are about your technology. Another question coming from Emmanuel is the analyzer able to ID the chemicals in the produced water?
Yes, it is possible. So as you do the calibration process, the customer can share with us specific oil types that they might have on their facility, and also specific chemicals that they're using. And we would use this information in our lab to properly calibrate the analyzer before it operates on site. Because equipped with a spectrometer, each contaminant will have a specific spectra. Using the spectra is like a fingerprint. You will be able to recognize as you do your daily operation if what type of spectra is introduced in the process. And you will recognize, is it a hydrocarbon or is it maybe another chemical that might interfere with some of the results. So yes, we can do that with the spectrometer, and early on in the project, we do the calibration to be able to recognize these different constituents.
Interesting. Now we're looking, I mean, from the same person, we're looking at it, I mean, a different dynamics of the question. Can you estimate the TDS in the PW with this analyzer? I'm sure we're talking about live experiences here from some of the operators. So can you estimate the TDS?
The most tedious is well, it's not as tedious as before, but obviously any piece of equipment, you have components, high technology, sensitive technology, or that can fail over time. Obviously, they're not as serious as before, but you can anticipate that your analyzer, or specifically the laser in your analyzer, has a specific lifespan. So lasers will last maybe 18 months, 24 months, and after that you will need to think about replacing it. The ultrasonic device, in some extreme conditions, might not clean your lens properly. But now, in the last couple of years, we've used a sort of a different technology related to ultrasonic. It is the rapid wave kind of ultrasonic, which I've shown you in the video where you saw the oil being removed from the lens. So this is a more intense energy that is pinpointed at the tip of the probe analyzer, to dislodge all impurities, and also has less impact on the lens itself. Ultrasonics device in the past had the issue where, yes, it is strong, it cleans the lens properly, but it could etch the lens, and over time, if you have an etched lens, after a couple of years, it can interfere with the proper reading.
Yeah, thanks, Sergio. I think there's a lot of interest in your technology here. I've got another question from OT, who is asking, how frequently does the LIF need to be recalibrated? And following that, how sensitive is the measurement to changing fluid properties?
Yes. All right. So the laser-induced fluorescence, we use the analyzer with a laser. So the laser emits this UV light, which is constant over its lifespan. I just mentioned earlier that they can last between 18 months to 24 months. But the beauty with the laser is it maintains the same light properties all throughout its lifespan. Unlike previous technologies using xenon bulbs, they can fade over time, so you need to recalibrate constantly or at regular intervals. With the laser, once you calibrate it, it will give you accurate readings all the way during the whole two-year span of the life of the laser. Okay.
Amazing.
And these lasers can be calibrated for different ranges. You can monitor, calibrate it to read between 0 to 1,000 ppm or 5,000 ppm, or a shorter range, 0 to 100 ppm. That is what we use in the industry. But you could have a specific application where you need to measure parts per billion, which is another magnitude smaller. So these analyzers can be calibrated to be very accurate.
Oh, thank you, John. I've got 2 more questions here, and they are very, considering our time. What about the inorganics in produced water? How is your technology taking care of this?
Okay, so these analyzers measure total hydrocarbons. Okay, so we are going to measure anything that will fluoresce. In combination with these readings, customers also send these results to a lab onshore where you can do further analysis of the specific constituents. And there you would recognize what is each component of your reading. And you can correlate and apply this in the future, knowing what is a proportion of inorganics or organic. Okay.
Thanks. I think I've got one interesting question from Kingsley. I'm sure he's tying this to the global environment, where we're talking of the green environment. That's where the world is going. The question is, how effective is your technology in the future from the point of view of energy efficiency?
Okay. Well, in terms of energy efficiency, like I said, these analyzers are self-contained. They operate with very little intervention from human intervention or operator intervention. So they will have so the discharge. So what is the? Can you repeat that question again?
Yeah. I mean, how
because I'm reading this through in the chat, but I cannot.
How is the last one? How effective is your technology in the future from the viewpoint of energy efficiency?
Okay. Okay. So in terms of energy efficiency, it will give you, very minimum impact. Because like I said earlier, the analyzer operates with 24 volt DC at very low amperage. But where you would save, I think, the most in terms of energy efficiency is if the analyzer recognizes that the water quality is within range, and you can divert the flow for not having to go through a tertiary treatment, let's say like filters, then you're avoiding to use pump skids, where pumps are really requiring a lot of energy to operate. And also you're not having to change the filters constantly, because water quality is achieved, you can bypass your tertiary treatment. So this is where you would save a lot on the energy consumption.
Amazing. Thanks. I think I'll be wrapping up with this last question. And the question is, I remember in 2019 when we had the privilege of having you face to face, and most of the operators were keen to engage with you. The question now is, the focus is on Africa. Do you have any pilot operating in Africa where our own delegates and their companies can engage and probably see how they can use this technology to optimize their operations?
Yes, we do have many projects in Africa where we're using these analyzers. I got projects in Senegal and Cote d'Ivoire, Nigeria, and many locations in Nigeria, Cameroon. And other projects that are ongoing. But it would be easy if someone would like to see it in operation, obviously with the approval of the facility or the owner, is, in Nigeria, we have projects with the NPDC. We can show how they operated and how they use it. And offshore Nigeria, we have customers that we could arrange going on platforms and show the operation and use this maybe as a pilot or as a reference point if, let's say, you're interested in adding this technology to your own facility.
Thank you so much. I think at this point, I know the questions are becoming very unlimited, and that is the show of interest in this innovative technology. John Mark, it's been a great pleasure to connect with you. I remember back in 2019 where we had a bus in Lagos, and at the end of our 3 days event, we had a spillover. Nobody wanted to leave. And I'm sure that's going to be a reflection of what we are going to experience today. We have more companies joining. Yeah. We have more individuals joining. You want to hang around, and I'm sure questions will be coming in the background. At this point, it's my pleasure to say thank you for your time.
Thank you very much. And I do remember a couple of years ago, we had a very good turnout. People were engaged, and it was a total success. And I hope I can go back to Lagos pretty soon and do it another time.
Your ticket is on its way.
Thank you.
It's a great pleasure. Thank you so much.
Bye-bye.
I appreciate it. Now, ladies and gentlemen, thank you so much for your time. And I'll be getting Lucy to join me here while we move very quickly into the next phase. Yes. Who else are you expecting? It's my pleasure to let you know that we have a gentleman here who is practically now an African in person, in blood, in face, in everything. His passion for Africa oil and gas is immeasurable, is infectious, and there's no other person who is wearing multiple hats today. You will have seen him from the start, and as we progress into this deep end of our presentations today, no other person than Mr. Steve Coffey, who will be presenting on external water solutions. He's representing the company External Water Solution. Mr. Steve Coffey, please, the floor is yours.
Thank you for that introduction. Well, I was going to be I was going to save us some time, but I got quite ambitious with my ideas from the last 2 days, talking to everybody joining the group, and I've essentially doubled the amount of slides. So I will probably have to talk very quickly to make the time to get through them. So anyway,
we can't see your slides right now. I don't know.
Yeah, I can't either.
Great. Okay.
This is well, let's see here. Nope. How about now?
We can see them. Yeah.
Now you can see the slides.
Yeah. Great.
Okay, and the complete slide.
We haven't got it in presenter view yet.
Okay.
So it's in presenter view, so we can see the notes.
Okay. Yeah, it's acting strange, huh? Okay.
So if you go back to that screen, and then if you go to there should be a button where you can
swap
that one. There we go.
All right. Very good. So thanks for help, Lucy. So as I was saying, yeah, definitely got very ambitious with what I wanted to talk about today. Initially, I really wanted to talk about sustainability, recycle, reuse, and some of the things that are, kind of more trending right now from an ESG standpoint. But in talking to most of you that are on the call now, and some unfortunately that couldn't join today, but will join later into the conversation, is the importance of some of the I'll call it the basics, the foundations of produced water treatment, and really from a primary and secondary standpoint, not really getting into the tertiary world that Jean-Marc had just mentioned. But a lot of what we do at Exterran is kind of on that further, secondary, tertiary treatment standpoint. But one of our newer product lines that we've added in the last couple of years has been more in the primary, secondary stage. And that's some of the products that I brought along with me from the company that I was with previously. Some of the IP that had been acquired over the years for hydrocyclones, both for desanding and deoiling, have come along with me. So a lot of what I'll be talking about is based on that technology on the front end of the conversation, and then on the back end, I'm going to try to make more room for the original topic that I had in mind. But I think it's really important to go through some of these foundational technologies, because when I did share back in 2019 just some very basic, where do I remove my sand type of approach, it was I think it was very new to most people at our all my roundtables and my presentation. So I definitely think it's worth a shot to go through some of these basics. So bear with me if this is, if it's too basic. But again, I think Exterran is becoming more of a water company today compared to what we used to be 65 years ago. The focus really now is on sustainability with these new innovative technologies, and in some cases not so new technologies. Now, these products have been around for 50, 60 years. One of our newer technologies was developed originally in 1982. So that would be the newest version of the technology. I shouldn't say version, because we're on Rev 6 or 7 of our deoiler right now. But the desander and desander hydrocyclones, whether it be a wellhead or a produced water treatment that's more of a compact design, all of these have been around and utilized in the industry for quite some time. And as you can see, I myself, with these products that I'm talking about, these small handful of products I'm talking about today, we have about 64 million barrel of installed product on the ground working today. So a fair number of primary and secondary treatment products available to you in the market. A lot of what we do is basic, I'll call it traditional produced water treatment, but some of it's a little bit outside of the typical produced water range, which would be a multi-phase, whether it be at the wellhead or well stream application, or a complete gas application, maybe with a bit of condensate. So from the desanding aspect, it could be a wide range of applications. On the liquid end of it, typically it's more of a traditional produced water application in the upstream market. We have a little bit of a footprint in the midstream market. We haven't done much in the downstream market, really, although the technology is used in that area, but that has not been our potential or our focus for now, and our potential focus for the future would be more on the upstream market and integration of systems. So I'm going to talk about really just 3 or 4 of these products. Again, well established in the marketplace, utilized in the oil field, both onshore, offshore, conventional, unconventional type of products in market sectors. The typical applications that we'll see are primarily produced water reinjection or secondary recovery. And probably secondly most common would be ahead of any sort of tank, whether that be a free water knockout or GOSP or a production separator. And then probably the third most common application, excluding the wellhead desanding applications, would be pretreatment. Now, whether that be pretreatment for a liquid-liquid device, whether it be a flotation device or a coalescing device or some sort of other tertiary device, or it could be ahead of a finer solid removal device. There's a wide range of possibilities there. And a lot of what we do is brownfield, going back in, taking a look at more mature fields where there's sand, where there wasn't sand before, or looking at where water volumes have increased because of maturing fields. So a lot of opportunities to take a look at old technology in new ways. One of our workhorses is this SDH device, which is made with a very robust silicone reaction bonded silicone carbide for longer life for the liners. Also, gives you a little bit more of this design gives you a little bit more of a volumetric throughput, and of course, best available technology from an efficiency standpoint with lower pressure drop. And our new sustainability reports coming out where we do address a lot of our carbon footprint and impact with some of these products. So I'm very excited to see what we do with it this year and able to publish next month with that. So some interesting, exciting things to come. Again, just one example of where some of the product would typically be located. Again, whether it's at the wellhead or well stream or further down at a lower pressure point with some ahead of some other devices for solids and or oil removal. A lot of these products are used in conjunction with onshore and offshore applications for a wide range of API oils, whether it be 8 API or 40 API oil, and a various a range of temperatures and pressures. Again, just more of what I was talking about, some of the key applications. All of these are based on Stokes' law, and there's really no way to to get around this. There's no tricking Stokes' law. I mean, it is based on relies on the gravity to separate, and some of the key factors that we're going to be looking at would be the droplet size, obviously the temperature, and of course the density difference between the liquid phases. So that they can have a major impact on the performance, especially if we're looking in areas where, let's say, in the desert where there's a wide range of temperatures, or a mature oil field, or maybe where some processes need to be improved upon. Maybe you have some shearing of oil droplets. There's ways that we can not only monitor but improve performance based on using technologies available today, just like Jean-Marc was mentioning with the analyzer and monitor. A lot of these technologies are already used to enhance and increase performance of the existing equipment and process conditions, but also in evaluating basically the process conditions for picking the best type of solution or product for the application. Again, wide range of products. Typically, we look at some micron sizes in most cases to break it down by certain levels by size. Just to give you an idea, human hair is somewhere in the 40 to 50 micron range. And that's also about the same size that the human eye can see, assuming you have good eyesight. And then, in the 5 to 10 range, or maybe 12 micron range, would be your white and red blood cells, respectively, to give you an idea for what we're talking about for sizing. So typically, your primary and secondary separation and filtration will be in that 15 to 150 micron range for the most part. Again, just to wrap up, our focus really with these more mature products have been offer a proven technology that offers some benefits like smaller footprint, more volumetric throughput, higher efficiencies. We've focused a lot on cost reduction over the years. I think we're now looking at something that's a fraction of the price it used to be. If you went back 20 years, the technology, just like many of the devices that we use today, the cost have come down over the decades. So that's been a big focus of ours. And then, of course, how to best and where best to apply the technology is key to the success of any technology. I'm going to switch gears real quickly here. I believe one of the things that I wanted to do here with this talk originally was talk about how to make some better decisions for produced water management and treatment, and with sustainability in mind. A lot of what we've been talking about this past year have been, I guess, crystal ball for where we're going with oil in general, but water tends to follow the trend very closely, with the one caveat that the water volumes actually if you look back at the trends, with the more, especially as the fields start to mature, you start to have more and more water that comes along with the oil. So these numbers typically, assuming that oil volumes even stay the same, these numbers will increase. And some of the numbers that are quoted for the 2023 number are up in the ranges of about 340 billion barrels per year, which is a dramatic increase from where we're at now, which is probably, the number that I like to typically use instead of the 210 billion number is the average for oil water ratios. Usually for a conventional application, you're somewhere in the 3 to 22 to 1 range. A lot of people use 5 to 1. Some people use 8 to 1. And it really has to do with where you're located and the maturity of the fields and the type of operation that you have. So there are definitely some impacts there, but definitely the volumes that we're talking about are enormous. We can definitely make a huge impact here with some smarter decisions, and moreover, changing the mindset. I think it's going to be very key. In the past, we've dealt with produced water or have considered produced water a problem or an issue to deal with. We really need to think of it as an asset, a valuable resource, and not a waste. If we're able to make these changes, the only way to utilize a resource is to give it some value. I've been told on various occasions that water is free and the water is unlimited. I mean, that's going to be further from the truth. And again, those are some of the bigger mindset battles that we have to challenge in the years ahead. But I do see a lot of changes. I think there's some focus on not only fit for purpose reuse, but also the beneficial reuse, like Dr. Alexandros spoke about with the reed bed application in Oman earlier today. That's a good example of how you can utilize large volumes of produced water that normally would be disposed of or wasted, or stored at a very high cost, or possibly treated and maybe reused, but only to a certain extent. I think there's some very innovative things that we could take a look at for beneficial reuse. And then there's a whole element of desalination. So, but I won't get into that right now. And I probably won't delve into the unconventional market too much, the shale play and or the heavy oil. But again, those are all great for possibilities for improvement. And I think, some of the things that are stopping us are, besides the pandemic, the oil price. Obviously, I think, when it's a stable price, things happen. When it's too low, people put the brakes on, and then quite frankly, I think when it gets too high and things are a little bit too good or people are moving too fast, I think a lot of not really great decisions are made, and I think that's a detriment to decision making when it comes to reuse and recycle. So I think it's going to be an interesting year ahead to see where we come out on the oil price. But I think the things that are most interesting are the environmental regulations, the measurement and monitoring and the reporting, especially with ESG in the as a factor now, will help make better decisions, hopefully, for water recycle and reuse. And then also water scarcity. I think the areas that don't have much water are going to be forced to think about more innovative ways to recycle and reuse. Again, there's a lot of reasons why it hasn't been done more in the past. I think a lot of it has to do with, quite frankly, we like to do what we've done before. So, doing anything different or new is not going to, be very favorable. Tend to repeat what we've done in the past, so that's a trend that we have to change. Also, I think that a lot of what we look at is what's the cheapest, and usually it's the cheapest today. And we need to make better decisions, not only looking at the CapEx, but OpEx, and maybe more of a longer range, not just a quarterly or annual snapshot. We need to take a look at a 5-year, 10-year, or maybe even 20-year sort of cost outlook to better make better financial and sustainable decisions. And again, policy and regulation again will come into place. The legality of who owns the water, what they're reliable for, responsible for, who's counting the number and constituents in the produced water. All these are factors that come into play that can work against us. But in some cases, if you change your mindset, I think it can work in our favor for increasing chances for recycle and reuse. Again, looking at the overall big picture, the characteristics of your fluid really need to be looked at first to better determine the equipment and the process configuration that you're going to use, and a chemical treatment program, and really how the product and your operation is put into play. If you don't take all these different areas into consideration and only look at one factor, I think you'll be missing out on the overall design process. And I think that also comes into play with many different types of groups, multidisciplinary teams that need to be involved. It's not just the reservoir engineer that's telling you that you need 10 micron or 5 micron performance at X ppm. And it may not be just the health and safety person that's talking about one aspect. I think it's a multitude of disciplines that really need to be looked at, and not only the different disciplines, but also the life cycle of the water, from the source to the treatment to reuse to storage to transfer, moving it from point A to point B. What you're going to do if you do reuse it, or if you don't reuse it, how to dispose of it properly and economically, and is there a way to maybe store it temporarily? But anyway, it is typically disposal is called disposal because it's never, more than likely it's not being stored of, it's being disposed truly. So I do think that that life cycle of the water has to be really looked at. So looking forward in some of the things that we can do and should be thinking about when we look at sustainability, obviously, anything that we're doing should not pose a safety risk. There's been a lot of talk about more cost-effective ways to come up with solutions. Again, the products I talked about at the beginning of this presentation were very old, essentially products and technologies, but they're a good fit for the application. So looking at fit for purpose and where things have been traditionally used, assuming they work, is important. I know everybody's excited about new technologies. I am as well. But some of the old technologies are have a good place in solving problems. I do think that a lot of what we're looking at for the future will be based on collaborative efforts. One of the reasons why I spend a lot of time talking to various different types of people in different organizations and events like this is the only way really to solve the problem is to talk with others and share success stories. So if we're not able to learn from others' mistakes or lessons learned, we're missing out there. Again, there's an amazing amount of information that we're not really capturing, monitoring, analyzing that we could be today. So I think utilizing information that's available or using technology that's available to do that is going to be key. And also there's I'm not just talking about the big data and the IoT, but just anything that you can do to do remote monitoring or visualization will be helpful in making better decisions, especially when it comes to recycle and reuse. Water quality, we don't really have a standard per se. We don't even have a guideline. Produced Water Society back just early last year published our first ever guideline, if you will, and it's very loose right now. And the first draft as far as what the parameters are for some suggested guidelines, not standards, for produced water quality. But again, it's going to vary dramatically based on geography, customer, I guess local policies and regulations, and perception of where you're operating. So there's a few things that have to be done to raise the awareness. But again, I think education on some of these basics that I talked about earlier today, with whether it's a hydrocyclone or looking at some of the monitoring that Jean-Marc had mentioned, or being more innovative with the approach of what to do with the produced water that Dr. Alexandros had mentioned in his reed bed application. I think those are all key for success and doing more with produced water. So with that, I want to thank you and open up for questions.
Thank you, Steve. That's a very, very effective presentation, precise and straight to the point. I think that is a massive takeaway from your presentation. The focal point is, which is reverberating across the African space, oil and gas space, is that produced water is not a waste, it's an asset. And I think the time has come for all operators across Africa to reevaluate and to engage. At the moment, the chat box is a bit quiet. And as we progress, we will give our participants, our delegates, the privilege to be in and out with questions. But we would sincerely want to thank you for this amazing presentation. We know Exterior Water Solutions is one of the world leaders in terms of providing solutions to produced water challenges across the world. And they have a specific focus on Africa. So for our delegates here and most of our companies here, you know exactly where to go to. Just hold Steve Coffey responsible for all the challenges that your asset is facing, and he will be there with external heart to provide solutions to you. Thank you, Stephen.
Yeah, thank you for that. And of course, very happy to, I've answered a half a dozen of you already with how to get more involved with PWS, Produced Water Society, in other regions. I mean, definitely, and of course in Africa. I think it's always nice to expand if you've got the time and bandwidth to share with other groups. And I say share, you also learn quite a bit, I think, when you get involved with the technical committee. So I definitely suggest that, any and all of you think about what you have interest in. And maybe it's not just on the technical side. There's several young professionals in the room that have reached out to make a difference in that way. So there's many ways that you can help and play a role.
Thank you, Steve. Really appreciate it.
Thank you.
All right. Thank you, ladies and gentlemen. Thanks to all our delegates, our sponsors. We want to use this opportunity again to thank you for staying with us. We know the room is becoming very, very warm. It's becoming heated up. There's a lot of innovation. There's a lot of technology that is evolving. At the moment, we will be moving straight to our next presentation. And as you are all aware, Boworld Energy is one of the organizers of this event in partnership with our global partners led by Steve Coffey. And we have one of the best world event management company, Brevity Anderson, who is working closely with us. They've all been amazing and fantastic. Boworld Energy as a company is having a major focus on Africa. And as we evolve, we have strong focus on produced water. And that arm of the business is led by a global veteran in the oil and gas industry, an ex-Shell expert. And he is the MD CEO of Boworld Water and Environment. I'm not talking of anyone else. Please, ladies and gentlemen, join me to welcome Dr. Magnus Ekekwe. Dr. Magnus, the floor is yours.
Thank you, Wilson, for, mic is off. Thank you, Wilson, for that. And see if I can get, won't take much of our time today. So just probably looking at things, sustainability from a different perspective, looking at more on local capacity building. So I'm going to talk a bit more about that, drawing from our experience and post-review work we did after the 2019 event. So just bear with me, I'll just share the slides. It's going to take too much of your time. Can find it. There you are. So I'll be talking about sustainable produced water management, making a case for industry and academia collaboration. A lot of things have been said about sustainability, and Steve alluded to the fact that not one person or one group can do it alone. So there is a need, an increasing need for collaboration between the industry and the academia. So from most of the presentations today, we've heard from some operators with their own experiences, and there are obviously operators in the background listening to this, being part of this. We've got equipment manufacturers, we've got produced water services companies, we've got researchers who have made presentations here and also listening. And so we believe that the Produce Water Africa event gives us, all of us, the opportunity to come, to connect, to explore, and like Steve mentioned, to share best practices so we can learn from one another's successes and failures, and make improvements where necessary. So I just want us to, having said all of that, to just imagine a world in which operators, academics, and other researchers tend to, work together, where we tend to adapt and develop and find ways of tackling the issues around water management in the oil and gas industry, where researchers, operators, academics work together to continually find better ways of doing things or getting better at doing them, in a world where research is not done in isolation, but where we try to maximize its impact and also help the industry to get their problem solved. In a world in which research really, really makes a difference. It's not just constrained or limited to the four walls of universities or research institutes. So what we know and what we found out from the 2019 event is that there's a lot of quality and interesting research being carried out in produced water treatment and management in the local universities in Nigeria. Some of these papers were presented at the 2019 conference. However, what we find out after the 2019 event is there's a lot of challenges in maximizing the output of this research work in the local industry. There seems to be little or no active collaboration, between the industry and the academia, in this area at the moment. So we're hoping to use this platform to kind of engender that kind of dialogue, collaboration, and networking. So the question is, why the disconnect? Why is it that a lot of people are doing work in universities or local research institutes, and then the industry is doing their own bit, and no one seems to be talking closely with each other? And one of the things we found out post-2019 event is that probably one of the reasons is that the questions being asked are perhaps not the questions that the operators or the end users want answers to. So we've got researchers, academics working on produced water treatment and all it involves, but without actually engaging with the industry, getting input in developing and building up this research work. And the other one of the third thing we've noticed is that there seems to be kind of two different cultures and drivers. Most of the time, the academics want to nail this to study to the nth degree, whereas the industry wants a solution now and today. And the last thing is that some of these findings or research work, which obviously are very good work being done, but they're not actually packaged well or properly disseminated, let people know what is happening. And what we find out that sometimes this is hard for researchers to do, without access to the right networks and contacts with the industry. And which is why we believe that having a forum like this, gives researchers, other stakeholders, operators, equipment manufacturers, the opportunity to actually engage and network with other people. So moving on. So what we find out from 2019 event is that, for research to be sustainable, it has to be seen to be solving real life problems that the operators have. Otherwise, it makes no sense for the operators to then start working with the universities in this regard. So what we're calling for is to say that there needs to be a much stronger emphasis on the co-production of research and development efforts. Basically getting the research and the industry together at the beginning of building the research work, so that all the parties involved, all the relevant stakeholders can actually set the priority for what needs to be done. And actually come back together and look at the results. How do we interpret the result? What does it mean for the industry as a whole? And then obviously disseminating this information into the wider community. And obviously we do know that trying to bring together different stakeholders, researchers, end users, to create a shared endeavor, does require to be conscious and deliberate. It wouldn't just happen on its own. It needs, kind of structure. So the question, I want to put to, the equipment manufacturers here, the operators on the forum, the academics on the forum, is, do we need a formal joint industry academia forum to engender, facilitate, and support this kind of work in the local industry, which obviously would then trigger a step change in research and development impact. So having such a forum, I've tried here to kind of highlight or identify what might be the objectives of such a forum. One, it would be to create a network of participants from the industry and academia. Provide an avenue for industry and other stakeholders to support relevant and active research in this area. And in doing so, maximize the local expertise. And also it hopes to build more local capacity in produced water management. It will help to foster an environment that supports homegrown solutions and not totally dependent on foreign companies to bring in these solutions, but we can find homegrown solutions. And hopefully via this forum, encourage the establishment of spin-off companies from some of these research findings. A lot of some of this innovative work, being, kind of sold to us from the developing world, kind of spin-off from work being done in the universities that becomes commercialized. So hopefully with this kind of forum, you can, have homegrown solutions, encourage spin-offs of small companies, create more jobs for, a whole lot of people. And also help to develop a suitable framework where there's a collaborative agreement that facilitates innovation and the handling of any intellectual property that might arise from this. We're also looking to kind of use this forum to improve the culture of collaboration and build a mutual recognition that the industry and academia are equal partners in this regard, rather than seeing each one as more superior to the other, but rather look at it as equal partners. And this obviously will be beneficial to everyone and help to improve training for the academics and industry researchers. So this is just kind of my thoughts on what objectives this forum could be used for. So the next question is, okay, what will be the benefits if we have this kind of engagement? Firstly, the academia will gain thorough and invaluable access to research resources, funding to deliver solutions to real life industry challenges. Because more often than not, what is being done in the four walls of the universities or research institutes are limited by funding. The basic research is being done, but how do we then apply it in real life? That requires additional resources, which more often than not, is not available to these institutions. So hoping that from this forum, there'll be resources and funding available. And for the industry, they will gain greater availability of early research findings, applications, and adaptation of this research work locally. So it will encourage, like I said, homegrown technical solutions and then less reliance on foreign expertise. Finally, it will breed a culture of collaboration and will build the profile and reputation of our universities, thereby attracting and embedding high quality research. So it gives opportunity for our researchers to actually network with other people in other parts of the world doing similar work. So who could be in this kind of forum? We're looking at, probably looking at researchers, universities, or similar bodies. Obviously, we need the active support from the local industry, the relevant government agencies. You know, we need the OEMs of service companies. We need international experts and bodies such as the Produce Water Society or the Produce Water Africa and a lot of other organizations that, you know, could be involved in this to make it happen. So that comes to the issue of, you know, obviously, like I mentioned earlier on, this type of forum requires to be funded. And so that's an issue that needs to be, you know, addressed. But I'm envisaging, we're looking at a scenario where the local industry and other relevant agencies will provide the necessary funding to set up and run such a forum. So this will ensure that the academics are supported by to engage in basic and applied research, you know, often in partnership with other researchers as well, and also supporting graduate research work in our universities. So we actually have our graduate students actually, you know, dealing with real life problems. But this requires, you know, the funding and the necessary resources to be put in place. So how do we move forward from here? I've just kind of tried to put together, you know, what my thoughts are on this. In a tentative roadmap would be like, okay, let's identify a team of academicians, researchers doing active work in this area that produce water or water treatment as in general. You know, could be to identify one or two local universities where this active research work could be domiciled and become centers of excellence in this. I know there are some work ongoing in Nigeria around this direction. You know, we then identify and engage with local operators and other end users that could fund and support this work. Applies to relevant government agencies as well. Engagement with other international experts and organizations to support such a forum. Just recently, you know, I know that Veolia, one of the oil services equipment manufacturers and service providers, you know, recently signed an agreement with an MOU with a Ghanaian university, you know, to test, you know, the concentrated effluent water in the mine water management system. So these are good examples of what can be attained or what is possible, you know, if there's a commitment and a determination to make it happen. So this shows a very good example of what is possible, where the industry and the academic world actually come together and make things happen. And lastly, I just want to say, you know, should not limit the conversations today to just, you know, within the forum, within the chat. You know, we should take these conversations outside this event, you know, should network, communicate with each other and say, you know, we are open to suggestions and ideas on, you know, does this sound like a good idea? Does this sound like a forum that people want to be involved in? You know, and hopefully we'll see you all in Lagos in 2022 for the third event. Thank you.
Thank you very much, Dr. Magnus. That's an, amazing presentation. I think some of your topics came up from some of the forum that I was in, and we actually had this. So this came up in some of our presentations earlier today, and we had the privilege to discuss it. You understand? I have a few questions here for you, Dr. Magnus. One is from Kingsley. You said in addressing the present gap, the service companies want research focused on real life problems, i.e., reducing the concentration of toxic pollutants. Why is it difficult? getting real life products.
I don't quite understand the question, but I'll try to answer it as best as I can. What I mean is that from the 2019 event, we had a lot of good technical paper potentially looking at how we can utilize some of the local materials, to replace some of the ones we imported, in terms of, what do you call it, filtration, looking at walnut filters. I mean, what do you call it? Part of it just escaped my mind. But basically, how we can use our locally grown materials that are readily available to replace some of the ones we import presently. And there's a lot of work being done in that area, but not readily available to the operators. And also, more for me, it's question of, can we get the OEMs, okay, like we've seen the example in with Veolia in Ghana, to actually engage with some of our local universities that are doing work in this area. Two things will happen. It will reduce the cost of implementing, produced water solutions in the country, because it's now homegrown. It will reduce dependence on importing of raw materials and things like that. So there's a lot of things we can do, but obviously it needs a lot of collaboration, needs a lot of people working together. There's not one solution. Every field is different. Every problem has its own, specific requirements. But what I'm suggesting here is potentially a forum where we can engage the OEMs, the operators, the researchers to actually come together. This has been done in other parts of the world. We have a joint industry forum, actually look at specific problems and look at how we can get better at solving them.
Thank you, Dr. Magno. I think because of our time, I'm going to actually limit the questions at the moment to just one. One is from Dr. Crit, and what he's saying is that it's a fantastic idea, bringing in the academia, the industry regulators, and all that. They're very important. And the big question is, how can this be implemented top down, both from the national and the international level? And I think you've touched on that. And the only way we can get this done is by engaging with the institutions that are involved, and they probably begin to discuss this. I wouldn't want us to spend too much time on this again. We can still bring it up during our general forum. At this point in time, we want to thank Dr. Magnus for this creative presentation. There is no world, no industry can evolve without research. And we want to, encourage all the African, players in this industry to embrace research, engage more with the institutions of learning, and so that we can have the opportunity to partner with some of these technology owners and bring creativity and innovation to the African oil and gas sector. Without much ado, what we have now is to thank Dr. Magnus for his presentation and quickly move to what is next on our agenda. What we have next is a kind of, we have a lot of sponsors with us here who made this possible. I mentioned this in the earlier presentation that Bowles Energy, Brevity Anderson, and the Global Produced Water, we are not a charity. We are all in business. But we're privileged to have a few companies who are with us today who sponsor this event. That's why you, as an individual, could be participating here live. This event costs a lot of hundreds of US dollars, but we are bringing this to you live at no cost as delegates. Can you please give us the privilege to showcase to you some of these companies who have been part of this movement over the years? I want to encourage Mr. Steve Coffey and Lucy to join us now while we load some of the videos on the presentation from Exterion. We'll be having company showcase from Jorin. We'll be having another showcase from MySelect, and the last one from Produced Water Society Global. Can I have Lucy and Mr. Steve Coffey here so that we can get this rolling? Thank you, ladies and gentlemen. Thank you for your patience. And it's good to see innovation. It's good to see technology. It's good to see the action. The new innovative technology that is ruling the world. Africa cannot be an exception. At this point in time, I've got with me Steve Coffey, and I've got Gratry with me as well. Good afternoon, ladies and gentlemen.
Good afternoon.
Yes.
Thank you, Dr.
So what
Wilson.
we will be going to now is at this point, we will be going to kind of live chat with companies to showcase specifics within their organization, specific technologies and all that, and that will crop into question and answer. So we will be moving from this company showcase to be represented. The first one on the list is Exterion. Exterion is going to be represented by Mr. Steve Coffey. You can see him there with his cup of coffee. He's been up since 1 a.m. You should pity him. I mean, he's living in a different part of the world, but because of you, he didn't sleep all through. Thank you, Mr. Coffey, for the sacrifice. We appreciate that.
Too excited to sleep.
Yeah, I know. I can feel you. Joining us is from Jarin. We've got Leah Trim. She's live with us at the moment. It's a pleasure to be with you. And thank you for the sacrifice of waking up so early and engaging with the global audience. And we'll have a representative from MySelects. We either have Matthew. I don't know if Matthew is here, Steve, or do we have Dr. Alexander?
No, unfortunately,
Okay.
neither.
Okay. And like I mentioned before, Mr. Steve Coffey is wearing many hats. You expect him to wear another hat here for PWS. I think the floor is now open. So this session will lead into question and answer, considering that our time is gradually fast spent. The floor is now open to you, Mr. Steve Coffey.
Well, thank you. Yeah, I see that there's some questions rolling in. I'll just start tackling them because I know we want to try to get back some time here. So Exterion does have 2 operations facilities in Nigeria. I'm not 100% sure on how quickly we could mobilize. It really would have to do with the scope of supply, since we do everything from, very small, quote unquote, off the shelf type of designs to very bespoke, huge facilities that would operate, 1 million barrels a day. So it'd be a wide range, but I'd say the majority of what I've seen based on my past experience in Nigeria with other, like the IOCs I've worked with in the past, would be a deployment typically of 2 to 3 months for a system. But it is definitely something that we're excited to look at and improve on. The other parts of our business from a gas processing, compression and power generation standpoint have been very good, even through the COVID period. So the last 2 to 3 years have been, we've placed a lot of focus in Nigeria, specifically to answer your question about the Nigerian operation. And of course elsewhere throughout Africa, Gabon, Cameroon, Cote d'Ivoire. I think I'm missing one more location, and of course in the north. Well, it's been a while since we've done work in Egypt and Algeria, but those are both areas that are currently part of our Middle East group. But our West Africa group is very keen to assist anybody and everybody with applications and opportunities to look at. I know that this year alone, we've been asked by ExxonMobil, Seplat, Chevron, and one more that I'm forgetting probably in the earlier part of the year, to take a look at various sort of applications, from just brownfield improvements to kind of redesigning a facility that was quite large. So some great challenges ahead, and I think it's for me, I can learn more from these questions and the sort of discussions that we have either today or offline or down the road, via LinkedIn or whatever. And we've got a good group of people in throughout Africa, but specifically in Nigeria. So I'm very happy to answer any more questions on that. I believe there's a second part, or maybe, the second part. More of a comment, I guess. Sorry, it is a question. Yeah, so I think all these products are, that we're talking about for the most part are proven technologies. However, we would probably take exemptions if we've not worked with a particular client. We would definitely take a look at some evaluation periods and pilots. We've done that for other NOCs in the past, and a couple of IOCs that we've not worked with in the past. So I would say yes to that, but to get more into the details, I definitely want to bring the commercial people into the discussion. But I would say yes and yes to both of those questions. So thank you for those. Making sure that I'm looking at the right screen. There was a question, Guthrie, I think about, I think the video was, somebody thought the video was on mute, but I think there was no sound on that particular video, correct?
On my video now, yeah. I didn't quite get the time to incorporate sound into it.
Yeah, well, we just threw some jazzy music on ours, so.
I should have thought of that.
Yeah, so I don't know if there's any question, but I've worked with Jordan in the past, and they're a phenomenal company and product, and obviously people here with us today that are super to work with. So definitely a leader in the industry, and very excited to be able to work with them again in the future in many different locations. So a bit of an endorsement, but I don't give those too often, but Jordan is definitely a great company and product to work with.
Thanks, Steve.
And Guthrie is not bad either. She's pretty nice.
It's very kind.
So this is an open forum. If anybody has any questions, comments, any, I think we do have a list of other questions from before. I didn't want to jump in right into the Q&A, but wanted to give everybody the opportunity to ask questions. I know I've answered a lot of questions along the way about Produced Water Society, answered a couple of MySelects questions, and definitely if it is if questions you're feeling that maybe you want to ask via email or text, that's fine as well. But if there's something that the group can take advantage of by asking a question, definitely that's the purpose of the fireside chat. Unless there's a fire and hot cocoa or something.
I'm not seeing any new questions pop up, but yeah.
Not yet.
What is John's?
I know we're running behind as well. Lucy and Blessing, if we don't have any questions in the next couple minutes, I was going to say I could facilitate a couple of my own, but I've answered so many of them. I don't want to repeat too many of them. Shall we jump into Q&A and open this up, and then so we can close up? And I know there's one more video that we wanted to play as well toward the end. So any suggestions on that, Lucy or Blessing? Wilson, you're back.
Hi, we've got one question there for Jerry, really. What's your offering for Africa?
Oh, okay. Yeah, so we hopefully the presentation kind of highlighted what we do. So we started off as being a equipment manufacturer. So we actually make these what we call like an online video microscope, these Viper systems. So we basically manufacture various models of that from lab scale, indoor safe area use, all the way to mobile hazardous area rated ones to actually fixed skids. So for permanent monitoring. And yeah, so, that is for worldwide market, but obviously Africa is exactly the same. You have the same needs, produced water monitoring wise. So our products are already in Africa, still going to Africa. And the other side of our business, other than just manufacturing the Viper equipment itself, is we actually do it's a consultancy service of sort. So with our mobile instruments, our Viper equipment, we actually mobilize that all over the world to customer sites for general process or produced water treatment optimization, troubleshooting, debottlenecking. We do chemical trials, equipment trials, feed studies. So the whole sort of suite of data that the Viper equipment can provide just gives you exactly the sort of information you need to know as to whether the process is working well, what can be better, what can be, made more efficient. And like I said, that's in terms of actually mechanical, the treatment side, but also chemical as well. And we also provide those services to Africa as well.
Thanks for that. I've got one more. What do you think, I suppose any one of you can answer this, what's the future for produced water, considering the downplay on fossil fuels?
You want to take a stab at that one first?
Not really.
Let me step in here quickly.
Sure.
Yeah. So I think it's a very good question. I mean, when you check what's happening in Europe, in America, and all the other parts of the world, you will realize that most of the assets, they are aging. These assets have been in production for decades. Africa came in late. Nigeria being the biggest African oil producing nation, it's still very young when you compare it to what is happening in the North Sea, when you compare it to what's happening in other parts of the world. So in as much as countries like Britain is pushing for 2030, 2035 to get rid of diesel, to get rid of petrol, most African countries, 99.9% of the African continent, countries, they cannot afford to switch off carbohydrates. And we're looking at decades behind. So the future of produced water in Africa, I call it a green environment. If you are an investor, if you are an OEM, service provider, Africa is presenting itself as an opportunity. Those your assets that are aging, that are dying in the matured countries, you have the privilege to bring them to Africa to help. For example, OPEC has allowed most of the African countries to keep producing because they know there is a need for energy. They know there is a massive push for exploration. Nigeria is not an exception, being the African largest producing country. Angola we have Egypt, imagine. We have many countries, Ghana and all that. So for the green revolution that is now the norm globally, yes, it's going to happen. But in the next 30 years, I can guarantee you, Africa will not get to where Europe or America is. So those assets that you have that is lying down there and not making money for you, I want to challenge every operator here. I want to challenge every equipment manufacturer. I want to challenge every innovator here. Partner with African competent companies. That is where your money is. And that's not going to disappear very quickly because we are decades behind the matured markets.
Yeah, I agree with all of that. And I'll also add that, even just looking at the US market, which is, in the past has been a smaller market, in recent years with shale play have become a larger market, but we've barely scratched the surface here. And our need for petroleum products and energy in general is not shrinking, it's growing. Actually, all consumption for all products that are used or used byproducts is growing. So I see that there's a huge potential, and especially because of the reasons that Dr. Wilson just mentioned in Africa, I also believe that I also do some work with some renewable type of companies and other alternative energy companies, and a lot of them use water. And a lot of them have the exact same problems or issues. It might not be BTEX that they're dealing with, but it's another constituent that they're having to deal with. So water in general, whether it's a byproduct of oil and gas production or whatever your process is, it's going to be key to the future. Water will definitely become more important, and water is becoming more important even in the oil and gas industry, as it's becoming a more interesting topic for people to talk about and listen to. So I think there's only room for growth, but I also think that we need to do it correctly. Just taking a stab at something and making quick decisions to make a quick return on investment is not the right way as well. So if you make it for a longer term real investment, I think the returns will be better, and also it will help the environment. I strongly believe you can do the right thing you can do the right thing in general and for the environment, and also have a healthy, profitable bottom line.
Okay, thanks for that. Karen, did you want to add anything to that?
No, I think Dr. Wilson and Steve covered it really. I mean, yeah, I know even Europe have a driver for 2035, but yeah, it's an idea in theory. We're so far behind actually being able to implement any of what they're trying to say. There's still decades to go really, so I think there's still lots that we can do in that time.
Thank you. I think we've got one more question. Do you think that advanced oxidization processes for produced water treatment have a future in the African market?
Well, I definitely would say so. I think any technology, mechanical, chemical, biological, has great potential. And if it is let's say, just throw one out there, ozone, for example, yeah, why not? I mean, anything that you can do. I know that Oxy and many other companies are looking at changing it up and looking at, changing the recipe of their treatment process in order to look at, using less chemicals. So I do think that if there's a new or new to Africa approach, it definitely should be, utilized and taken advantage. But again, it's going to take trial and error and opportunities, but I do think that there's a good market for that as well.
Thank you. I think I've got one more that's just popped up. I'm not sure who it's for. Hydrocyclone is tailor-made to meet specific treatment needs for each individual exploitation site. What is your company doing in terms of developing compact systems capable of treating more pollutants? Would that be you, Jorin, or would that be you?
That must be for Steve.
Yeah,
Okay.
That's me.
Yeah.
I'm just rereading it right now. Yeah. So one of so it's kind of a two-part answer. If I'm getting the gist of this from Kingsley, the gist of a tailor-made product. Well, one of the things that's happened over the years with hydrocyclones, it's become a bit of a commoditized product actually, and we've gotten really good at not only making it more robust and compact, but a lot lower in cost. Along with that, we've also tried to expand our scope of supply, not only from the bells and whistles and the tertiary treatment that may go along with it, but from our side to offer a wider turndown, so that in fields where you have various mature wells coming on and off, that you're able to utilize more of one piece of kit versus having one individual for each individual well. So we've done a lot in terms of turn down ratio in order to get better at reducing the footprint. And that's obviously something that Exterran continues to do with all their product, whether it be hydrocyclone or flotation. The advancements that we've made in flotation in the last 10 years have been amazing. I'm kind of surprised because I'm not coming from the flotation world, I'm coming from the cyclone world. So it's amazing when they make advancements, not only in footprint, but also in CapEx, OpEx. It's pretty impressive. So, how to treat more pollutants. I'm thinking, I'm not sure if I'm missing that second part of it. I think that maybe you're related to a wider range of constituents, which would entail basically the larger, turn down ratio, but also maybe the larger contaminant. We definitely have focused a lot of attention in recent years with iron and iron byproducts in the oil and gas space. So that's something that's come out of the shale, mainly the U.S. shale play industry. So there has been some advancement. So yeah, I think the cyclone is something that you can utilize in many different, can wear many different, play many different roles depending on how you utilize it. It's used quite frankly in many different industries. So I think we could apply it in many different ways.
Thank you. If you have any more questions, feel free to type them up and we'll try and answer them maybe in the chat. But I'm going to say thank you to you all for joining us on this session, and I'd like to move on quickly to the next session. We've got a video to show you, it's quite short, from the Honourable Minister of Petroleum Resources of Nigeria. So please hold on for that, and then afterwards I think Steve will come back and have something to say to us all.
Well, I love that video. I will be there too. That's a great slogan. Just like Nike in the old days, just do it. This is very, obviously a different experience than in 2019, but it was great to visit with everybody virtually today. I think it might be just as tiring to do a virtual event as it is a live event. And for me, I don't get the personal connection and charge that you get with the real face-to-face that I always enjoy. But it's still been a very insightful day, a lot of learning from each other on many different levels. And again, very thrilled to have everybody that participated today, including our sponsors, Produced Water Society, Groundwater Protection Council, SPE, World Oil, and of course all of our sponsors, Exterran, MySelects, Joran, Envirotech, Turner Designs, Produced Water Solutions, Bullards Energy, and Brevity Anderson, ExxonMobil, Seplat Petroleum, and SB Nigeria. And we had some great speakers today. Want to thank the speakers. I know, it doesn't seem like a big time commitment, but the preparation that goes into a lot of these talks and being well prepared, it does take some work away from your day job. So I applaud everybody for taking the time and sharing and giving to others of your time. I encourage everyone that's already working in produced water to actively participate in this forum and others. I'm actively supporting this initiative by bringing in people from my sphere of influence. And I again encourage everybody to submit technical presentations or abstracts, and also nominate either your colleagues or subject matter experts that you know or know of, and we can approach them to get them involved as a delegate, speaker, get them more involved for the next event. I also encourage any organizations to participate in sponsoring. There's a lot of different interesting ways you can sponsor and offer, a preview into technologies, whether you're a supplier or even if it's I've talked to several folks that are in the chemical world who we don't normally talk to, but are making efforts in Africa. So I definitely, if it's a water discussion, I think we should invite the folks to the discussion. I really think that the collaboration in the year ahead will be important to our success. I think if we're trying to do everything on our own and by our own will and in our own way, we will not have the success. If we do more together, we will do more. And I think we can make it a lot easier. I know that everybody's feeling a little bit more stressed than normal. I'm still not really sure what that's about. I feel it too. But, you know, getting together like this and sharing information helps make, you know, the days a little bit more like the old days. You get to share and see faces from the past and meet new friends and learn new things. So I'm very excited about the year ahead. I think having some new and previous IOCs and NOCs involved and playing a major important role in what we're doing today, and like setting some benchmarks for best practices in the region. I think you know, the case studies that we were talked about today and that we were asked about, I think bringing those case studies and lessons learned from other areas, or in many cases, you know, just older case studies from the region, I think we have a lot to learn from that. So I definitely extend that invitation out to any suppliers, OEMs that are not here today. And we're going to be reaching out to a lot of folks to try to engage them. And I think the innovation can have a major impact on what's happening in the continent. So again, like we did in 2019 and what we did today, you know, next year's conference will be the hybrid of that platform. And I think, you know, it's going to be a great platform for unveiling new innovation and really networking, especially for the folks that may not be able to make it to an event or maybe make it to an event the whole time. I've attended and been a part of several hybrids, and I can tell you they're definitely, once you experience one or two, you really can take advantage of more. And I think that offering this in the future, it will be great to see everybody's face, but I'm also relying heavily on the virtual element in the future of doing business. It makes it, it's just another, you know, one more spice to put into the soup. So I'm excited about what's ahead. I think your companies and all of our stakeholders will definitely appreciate what we're offering here from an educational standpoint, and offering this as a hybrid should only help us further reach a bigger audience and hopefully make an impact on a more long-term you know, scheme. And again, finally, you know, abstracts, the call for papers, abstracts will be coming out next month. So if we can get some activity going before the end of the year, I know when we get into the holiday part of the year, it tends to be more difficult to do those sort of things. But, you know, we'd love to have a good showing next month and have some great technical discussions. I've had many people ask me today about being on the technical committee. If you're interested, definitely let myself or Dr. Magnus know about your interest to participate. And again, thank you for everything that you know, gave today. And I trust that you made the most of it. And definitely want to wish everybody to be safe and healthy, and wish everybody the best for the remaining part of this year. And I look forward to seeing everybody again next year, either on the screen or in real life. I will be there. So again, thank you so much. Cheers, everyone.